I know what intro means, so there's no point in writing out introduction, right? Okay, intro to equations. Alright, throughout the day, I don't really use colored pencils on this. I think I used red once. If you want one colored pencil, you can. Otherwise, you probably don't even. Alright, who can tell me what is one of the key parts of an equation? What makes an equation an equation?
Not having an answer.
Not necessarily having an answer. The equal sign. So an equation means that we have that equal sign. What does it mean for things to be equal? The same, exactly the same. So that's why in today's day and age, when we talk about equality and equity, they're almost the same thing, but they're a little bit like everyone gets the same thing. So when they did those, like the COVID welfare checks, right? I think every family got those COVID welfare checks. We got not the welfare. That wasn't the right word. What was it? Stimulus checks. Everyone got that. That was equality. Everyone got it. Equity would be more like making sure people have enough for a livable wage. Okay, so if you have enough money to live, maybe you don't need that extra money versus somebody who doesn't have a job. They might need that extra money to make sure they can buy food. So equity isn't necessarily everything is exactly the same. It's a little bit more like everyone is at the same playing field. Okay? All right. But today we're going to be talking about equality, and equality has that everything is the same kind of thing. So there are 3 classifications to equations. Our first one is the one that we are the most familiar with, and that is a true equation. So for an equation to be true, that means it works. So if an equation works, then both sides should be equal, right? Or the same. That would look weird. So, like 5 equals. What does 5 equal? 5. What? Crazy, right? What about if I say 16 plus 2 equals 18? Is that a true equation? Yeah. Does 16 plus 2 make 18? Yep. Okay. True equations can also look like 3x minus 2 equals. What's happening?
You said that 5 equals 6.
5 does not equal 6.
That would be a not true.
That would be a not true. Alright, if I have an x and I have like 3x minus 2 equals 3x minus 2. Does 3x minus 2 equal the same thing as 3x minus 2?
Yeah.
If you take a number, multiply it by 3, subtract 2, are you going to get the same thing as if you take that number, multiplied by 3, subtract 2? Yeah, you're doing the same thing to it. So those are the same. So we get that true equation. Doesn't matter what number we put in for that x. All numbers we put in for that x, it's going to be the same thing. All right, so if we have a true equation, what might be our next one? Taylor said not true. False, yeah. So a true equation is when both sides are the same. What is a false equation? When both the sides are different, okay? Or they're not the same. So the sides are different, values are different amounts. So for example, 5 equals 6. Does 5 equal 6?
Yes.
No. So to show it doesn't work, we put that little slash through that equal. It just means that they are not equal. It is not the same. Okay, what about 5 times 3 equals 10 minus 4? Now you're probably like, it's false because we're writing it underneath the false. But I want to know why. Okay, 10 minus 4 is 6. 5 times 3 is 15. Is 15 equal to 6? No. So that turns out to be false. What about if I have W plus 4 equals W plus 10? Is there any number for W that this would work for? No, because if I start at a number and I jump 4 spaces, and then I start at the same number and jump 10 spaces, is that going to end up at the same place? No. Okay, so that is also a false equation. We'll talk a little bit more about those types of equations next chapter, but right now it's false. All right, last one. This is the one that maybe you haven't heard before, but you work with a lot during math. So you've worked with these, you just don't know that this is what we call them. We call them open equations. And with open equations, there's not enough information. So it could be true, but it also could be false. Okay, so for example, if I have x plus 2 equals 7. Now, x stands for a number. Really, right now it stands for all numbers because we don't know what x is. It doesn't tell us. Do all numbers, when you add 2, you end up at 7? No. Is there a number that works, though? Yeah, what number could x be? If x is 5, is it true or false? True. But if x is 4, false. We don't know. It doesn't tell us what x is. So this ends up being an open equation. What about 3y equals 5y? Is there a number for y that could make it true? What number, when we multiply it by 3, do we get the same answer when we take that number times 5? 0. 3 times 0 is 0. You're thinking 1. That's okay. 3 times 0 is 0. 5 times 0 is 0. But as soon as you put in any other numbers, like if we put in a 1, 3 times 1 is 3. 5 times 1 is 5. That would be false. So it could be true, but it could be false also. All right, and then we also have where we can combine those variables. Like if I have x plus y equals 10. Is there just one exact way that this could be a true equation? No. Could be a true. What could x and y be to make it true? 5 and 5. Like x could be 5, y could be 5. 9 and 1. 7 and 3. 6, 4. 20 and negative 10. 8 plus 2. 1.5 and 7.5. 8.5? 1.5? Okay. So there's a lot of different numbers that could work for x and y here that would make it true, but there's also a lot of numbers that would make this not true. For example, if I did 100 plus 17, does that make 10? No. So we don't know. We'd have to have it tell us what x and y or those variables are for it to be true or false. All right, so we're going to do 2 quick examples, and then we're going to practice this, and then we'll go back to notes for a little bit. Okay, so for example 1, we're going to be asking ourselves, is this true, false, or open? Alright, so we have 4x. I'm sorry, 4 times the quantity. My bad. 4 times the quantity of x equals 5 times the quantity of x plus 6 minus x. Right now, just taking a look at it, do we know enough information for true or false? No. So a lot of people, when they're like, oh, I don't know if it's true or false, they just say open. We don't want to jump to that open conclusion until we've simplified those sides as much as we can. Do we know a way that we can make this simplified? Yeah. What property do we use to make that simplified? Distributive. We do that. Pew, pew. I like to draw my line down the middle so because I'm going to keep things on this side, keep things on this side. So I go pew, pew. Okay, if you need to write out that multiplication, you can. You don't have to if you're feeling like you know how to multiply. 4 times x. And then we'll do 4 times 9. Eventually, I'm going to be skipping this step as well, but for these first couple times lessons, we're going to be doing them out. Now, when I see x like this, how many x's is that? Sorry. Just that x there. 1. So this is really like 4 times 1 if you need to. But then 4 times 1x is 4x plus 36. That's okay. If you need to use a calculator, that's totally fine at this part. Not worried about you guys knowing your math facts. If you know them, great. If you don't trust yourself, that's okay. Now I want to see, does that equal the other side? I probably shouldn't have put an equal sign there. Sorry. My bad. Got excited. Alright, so now can I simplify this side? What do I need to do on this side? Same thing. Distribute. Pew, pew. So 5 times x. And we're going to do 5 times 6. Do I need to do 5 times this last x? No, because I didn't draw an arrow there. It wasn't because of the arrow. Why don't we need to do 5 times that x? Good, it's not in the parentheses. So 5 times x, 5x, 5 times 6, 30. But then I still have that minus x attached on the end. Is this as simplified as I can make it? No. What else can I do? Yeah, I can do that 5x minus x. Again, how many x's is that when we see x? It's just one x. In math, we don't always put that 1 there because it's implied. Similar to if you ask your teacher for a pencil, is your teacher going to ask you how many pencils do you need? Now, if you ask for a pencil, how many pencils will they give you? 1. Because it's implied you need 1 pencil. You didn't ever say you needed 1 pencil. You just said I need a pencil. Same thing here. When you say minus x, it's the same thing as base. So I can combine my x's. 5x minus 1x. What is 5x minus 1x? 4x. We're subtracting. So 4x plus 30. Can I simplify that? Nope. So for my final comparison, I'm looking at 4x plus 36. If you want to rewrite it, you can. Equals 4x plus 30. So in this one, it starts out the same with that 4x. Then this time, whatever that number is when I do 4 times x, on this side I'm adding 36, and this side I'm adding 30. Are there any numbers that when I add 36 and then I add 30, I get the same number? Nope. So is this true, false, or open? False. All right, we're going to do one more example, and then we'll do a little bit of some practice, and then we'll go back to notes. It's kind of like a jump back and forth day. All right, number 2. We're going to number 2, and then we're kind of moving on. It's like the same topic, but a different topic, so I go to the next page. But all right, so again, we're going to do true, false, or open. That's the question that we are answering. All right, we have 4x minus 13 equals negative 3x squared plus 7. At this exact moment, do we have a way of simplifying either of the sides? No. And do we know enough about 4x and 3x squared to say that's true or false? No. So we would say open. But we're going to just change it just a second. We're going to say that x equals 2. And you kind of like put a comma in between. It's weird. So if x equals 2, can I now simplify both sides? Yeah. Can I evaluate both sides? Yep. Evaluate means to, what would our answer look like? No. Evaluate means to like just get one number as our answer. So we're going to have 4. And 4 and x, they're right next to each other, so I can use parentheses. Or you could write times 2 minus 13. I like to switch those out right away for both sides before I start evaluating. Does anyone remember that mathematical term for switching out? You do it in soccer a lot, in volleyball, when you switch out. What? What do you call the person that you're switching out with? A substitute. So this is substitution. We switch them out. Okay, it's like a player going in for another player in the game. All right, so on this left side, I have multiplying and I have subtracting. What should we do first? Multiply. What is 4 times 2? 8. Just brain's thinking too fast, answer. Slow it down a bit. That's okay. All right, now I have 8 minus 13. So since I have a smaller number subtracting a bigger number, what kind of answer do I know I'm going to get? Negative. And then once I know it's negative, I can kind of flip these around in my brain, or we could just use a calculator, either way. So we can think, what's 13 minus 8? 5. So negative 5. All right, so now let's try the other side, see if we get the same thing or something different. So on this side, what am I going to do first? Good, the exponent. You got it, the squared. So 2 squared, what does it mean to do 2 squared? 2 times 2. And what is 2 times 2? 4. If you didn't need to write out 2 times 2, that's okay. You don't have to. I'm just writing it out to make sure that we're all on the same page. Now what? Times. Do these parentheses count as a grouping symbol here?
Yes.
What's the thing it's grouping?
4.
4. All by myself. And there's only one thing in there it doesn't count as really grouping symbols. So negative 3 times 4, negative 12 plus 7. Here I have a negative and a positive. So to know if my answer is positive or negative, I have to look and see what do I have more of. Yeah, I have 12 negatives and I only have 7 positives. So I'm going to get a negative, and then I'm going to subtract because they're going in different directions. Negative in the positive direction, 7. 12 minus 7, 5. Maybe. So is this true, false, or open? True. All right, you cannot guess if the third one's going to be open because we're not doing a third one. All right, we are doing more notes, but we're going to switch it up. We're going to do a quick practice with this true, false, open situation that's happening. Okay. So, feel free to keep going. It's your choice. Okay, but I'm out of space, so I'm going to go to the next. Alright, this is also our intro to equations, and really what we're going to be doing the rest of the time with equations this chapter is solving equations. What does it mean to solve an equation? Kind of to answer. To figure out what? Yeah, to figure out the answer. Good. To figure out kind of the variable. If you guys look, Taylor was like, oh, but here I could divide by 2 and then 2 equals x. So Taylor found out that if x is 2, this works. But if x is not 2, it does not work. So she said it was open. Okay, good. Good. It was Taylor, Lucy, and Lauren. Sorry. It wasn't just Taylor. They were all doing it. Alright, so solve means to find the value. Of the variable. To make a true equation. I wrote really big. Okay, so to solve, we do get an answer like x equals or y equals, but our goal is to get a true equation at the end. Bring it back to my. Alright. So, for example, if I have x plus 2 equals 6, and I asked you to solve that, you could show your work. We could do it the whole way that we've been taught to solve it. Or we could just think to ourselves, what number plus 2 equals 6? 4. So x would have to equal 4. That would be the solving. Saying x is 4. If x is 4, then it's a true equation. All right. Then we have inverse operations. So if you invert your computer screen and you do inverted colors, what does that mean? Yeah, it's like opposite colors. Whites turn black, black turn white, red, orange turns is purple. Blue? Something. And then there's a bunch of yellow on there. It's just all sorts of nuts. Okay, so it kind of means to like flip it or to do the opposite. In math, our technical definition is going to be operations that undo each other. And we're going to be doing this when we solve equations. We'll use inverse operations when it's questions that, like maybe they're too big questions to just do in our head, like x plus 2 is 6. We're going to do those inverse operations to solve those equations. So if you see something that is a plus 2, how would you undo a plus 2? Minus 2. Or vice versa. If you saw a minus 2, you could add 2. They kind of switch back and forth. If you see a times 3, what's the opposite of times 3? Divide by 3. Now this one's a little tricky. If you see a plus negative 6, how would you undo adding negatives? Subtracting a positive would actually make you go more negative. You could subtract a negative. Do we like to subtract negatives? No, you guys were really good on this on the first day. When we subtract negatives, it's the same thing as adding a positive. So negative 6 plus 6. That gets us back to 0. So adding and subtracting, a positive 2 and a negative 2 makes 0. Negative 6 plus 6 makes 0. But what about like a times 3 divided by 3? What's 3 divided by 3? 1. And we'll talk more about why is that one 1, but the other ones are zeros in just a second. So we're going to do 3 examples. They go by pretty fast. All of our examples, our directions are to solve. Okay, so example 3. Really, I don't know. Some people wanted to start over with example 1. If you want to, go for it. All right, if I have j plus 23 equals 49. Couple ways to solve that. You could guess and check. You could just try and figure it out in your brain. Or what we can try and do is isolate that j. Try and get it so it's just j equals. And get rid of that 23. We don't like that 23 there. We want to just j. So how would I undo this adding 23? What would be the opposite of adding 23? Subtract 23. Why do I have to do it on both sides? Yeah, remember we talked about that equality idea at the beginning of class when equality is like we do the same thing for everything? I draw my line down that equal sign. That helps me keep things equal, and it helps me keep track of where am I subtracting that 23. I don't want 2 minus 23s on this side. I want 1 on this side, 1 on that side. Okay, 49 minus 23, 26. And if we wanted to see if we're right, we can just double check that. Okay, we go to our calculator, 26 plus 23, design j is 26, it works. Alright, example number 4, I'm going to go off to the side here. You can go up below if you want. I just don't want to run out of room. So I already used 2 pages. Negative 64 equals b plus negative 17. When I solve, I instantly draw that line down that equal sign, just where that equal sign is. Okay. What do you notice is different about this one compared to this one? There's a negative, a couple negatives, right? Yeah, the variable is on the right side this time, or unknown is on the right. Is that okay to have our variable on the unknown on the right side? Yeah, it's going to happen a lot this year. So some of us might feel like this is really uncomfortable. 64 here and b plus negative 17 here. But it's going to happen so many times this year that we should just like uncomfort. Soon this will be our new normal. Okay? So to get b by itself, I want b all alone, but it's on my right side. So what is on the same as that b? That adding negative 17. So how do I undo adding negative 17? Good. When I have an adding a negative, I'm going to add a positive. That gets me back to that 0. And if I do it on one side, do it on the other. That's equality. Not necessarily equity, but equality. Okay, if you are using your phone calculator, which I don't recommend, I really love when you guys use Desmos, but if you are a calculator, we always want to use this button. We don't want to use that minus button. So you can hit that negative 64, okay, plus 17, negative 47. And if we want to just double check it, we can plug it back in. We substitute it out. Where this b was, we're going to say is negative 47, and then just double check, plus negative 17. That didn't work. Try it again. Negative 47 plus, sometimes you have to type in the 17 and then hit that negative sign, and we get negative 64. Alright, last one. And then you guys just have a quick check today. Remember, that's only like 3 questions. It's really fast. See if you get it. Okay, number 5, last one. This time we have negative 7y equals my goal is to get that y by itself. What is with that y? Add 7 to both sides? No, what am I doing with that negative 7 and that y when they're touching? Multiplying. So since they're multiplying, if you want to rewrite it with that times in there, you can. If you don't need to rewrite it, don't. That's fine. I'm not requiring it. I'm just so we can see our thinking. So now that it's a times, what's the opposite of times? Divide. So I'm going to divide by negative 7. When we divide by that same value. Okay, negative 7 divided by negative. When I take a number divided by itself, it's just 1. And remember we talked about that. 1y is just y. And then 84 divided by negative 7. Ew. 84 divided by negative 7. Negative 12. Alright, so today you have it's a fast, quick check. It's 3 questions long.